So now let's actually code up our third order scheme. So in order to code up the third order scheme, we are going to be using one time step of midpoint, okay, so that we get the 3 steps. And then let's starting from step 3, and that's our derived scheme. All right. Okay, so how do we apply our derived scheme? We compute the right-hand side, right? And my u next is going to be application of this rule. It's going to be, instead of un minus 1, it's actually minus 3 over 2 times un minus 1. Un. And that's un is this u at t, right? And now I plus 3 times un minus 1. Our minus half times un minus 2. Okay, and I'll have right hand side not times 2 delta t, but times 3 delta t, right? Okay, good. So let's actually run it to see what we get. Okay, it finished. And now let's plot the result list on the log-log plot. So the blue is forward order, red is midpoint, and this is our third order scheme. This is interesting, like one of the most unexpected result we can get, right? Actually, as you started working through this semester, you might see this, right, in your own schemes if you are not careful enough. This is because we have, for the first time, encountered something called instability. Our scheme is unstable, right? As every time you see something like this, I'm actually going to look at the workspace, right? We have the end list and we have the result list. Let's actually open the result list to see what it gives you. Okay, as we can see, we have 4 numbers that are increasingly larger, and then we get not a number plus not a number times I. So whenever you see something like infinity, not a number, that's indication of something like that. A scheme that, however you call it, has blown up or goes unstable or something like this. Okay, why? What actually happened?